Hello and welcome once again to my YouTube channel Dimpy 101. So this is our video number 5, and we have already recorded 4 videos in this series in which we are going to create a robot which is going to find its way around the obstacles it's gonna see on the while it's traversing through the plane, and it will go ahead and decide which way to move based on where the obstruction is. Now, in the previous 4 videos we have done some basic programs in terms of blinking some LEDs, and we have also done in terms of moving our wheels forward and backward using the Raspberry Pi and the geared motors. But so far we have not used any sensors in order to achieve our target. Now, as I told in the previous video, that we are going to use an ultrasonic sensor this time, which will help us to identify the distance of the obstruction. The thing with ultrasonic sensors is it has it works on a sonar radar kind of a technology, wherein it shoots a sound wave, and then when that sound reflects back and it receives it, that is when it will detect that there is something in the front. Now, since we know the speed of sound, so by the time it has taken for the sound to go hit the object and come back, we can calculate how much distance is of that object actually. So we can take the help of sound to go ahead and identify. And most of the projects that you will see which have made this kind of projects before, they have used ultrasonic sensors. Now, for our demo purposes, we are going to use only one ultrasonic sensor as if now, but later we will add 2 or 3 more sensors to our vehicle, and that will help us to identify the sound, the obstruction from all sides. Now, the challenge with the ultrasonic sensors is that when it fires a wave of sound or burst of sound, then what happens is the sound wave, first of all, it's a high frequency, we cannot hear it, and then if it goes and fires it, if the object is at an angle, or if it is a round shape object, or if your vehicle is at an angle from that object, so it becomes difficult for the vehicle to identify the distance of the object. So for that purpose, we're going to use more than one sensors to help us get through that. Now, if you see our program, which is our previous program here on the screen, now this program does actually we define functions for forward, reverse, left, and right functions, and we call them to perform the said activities. Now what we're going to do is we will open up a new page, and in that new page we will go ahead and write a small program to test the ultrasonic sensor, and once that we are done with it, we will go ahead and use that program, copy paste it in our original program. So now let us just go ahead and start with it. So what I'm going to do is I'm going to import time. I'm going to import RPI GPIO as GPIO, and then we're going to use GPIO set mode as GPIO dot board. So this is the basic setting of our Raspberry Pi board. Now what we're going to do is we're going to go ahead and set a pin for trigger. So this is our ultrasonic sensor. Now as you can see, it has 4 pins. So one pin in this is for ground, one is echo, one is trigger, and one is VCC. So the ground pin, what it does is it's for the ground connection. Echo is the one which listens to the sound. Trigger is the one which fires the burst, the sound burst, and then VCC is for the 5-volt current. Now what we're going to do is we're going to define our pin for trigger. So what I'll do is I will keep it as pin number 16. Now this does not mean that I'm going ahead and keeping the pins. I'm just defining a variable which will help me to go ahead and set up the pins for later use. So instead of using that number 16 each and every time, I can simply use GPIO trigger. What this means is GPIO trigger label is equal to number 16. So wherever GPIO trigger is used, it will understand it as 16. So now it is for our easier understanding that we're going to use these variables. Now I will just go ahead and say echo, and then I will use it as friend. Echo front is 18, and I will use this echo front as 18 so that I can use my this variable for listening. Now in here, GPIO dot setup is GPIO underscore trigger dot out, because it's going to fire the impulse, so it's going to be output because it's going to send an output. Similarly, because our echo will be expecting echo front will be expecting an input, so we'll type it as in. Now what this does is this will just go ahead and set up our GPIO.in. Now I'm going to go ahead and set my GPIO dot output GPIO underscore trigger false. So I'm just setting it as false so that to reset itself, which I will give it maybe 0.2 seconds, which is more than enough. Then I will just go ahead and fire my GPIO pin, GPIO dot output GPIO underscore trigger is true, and I will keep it firing for maybe 0.005 seconds, which is even more than enough time for it to go ahead, and I can actually go ahead and do it 0.0005, even that would work. So but we'll just, since it's the first time, we can later optimize the timing on it. Now once this is done, GPIO dot output is GPIO underscore trigger is false. So this is time. So this the variable which says start, so whatever that present time is, it will record that time. So whatever the time, and this will go up to microseconds. So we can just go ahead and do that. Now what we need to do is we need to go ahead and say while GPIO dot input echo front is equal to 0. If in case, so what this means is, what 0 defines is that it has not received any input. So what it does is, till the time that echo dot input is 0, so you keep recording time. So what that does is it will keep on recording time regardless of, sometimes because our sound burst might come in, maybe 1 microsecond, and sometime it might take 2. So depending on how far the object is, so till the time it will keep on firing it. If in case while GPIO dot input echo front is equal to 1, if in case it receives an input, so let's say stop is equal to time dot time, so it will go ahead and record the value of stop time. Now we have a start time and we have a stop time. So what we're going to do is we are going to subtract the start time and stop time, so this will go ahead and give us the value of how much time it has taken. So elapsed is equal to stop minus start. So this gives us the value of this thing. Now we need to find the distance. Now what this means is that I need to find the distance of how much time does it take, and let's say we find the distance is 343. So the speed of the sound is 343 meters per second. So to get this to centimeters, we multiply it by 100. So that is the speed of the distance in centimeters. Now, because this is the time from the time the sensor fires it and it hits the object and it comes back, that means this is calculating the double amount of time. One is for going for the sound burst, and then the second is for coming back of the sound burst. So to get the actual time, so what we need to do is we need to go ahead and divide is into 2, and then we'll say front is approximately distance integer. So why did I type this is because what this will do is this will normally when it divides by 2, the distance, that the value that we get will be in points. So you can keep it in points if you would like to, but I like to keep it in integers. So I have converted that distance which was in points into integers, so it will leave all the value which is after the point. So this will give us the actual distance. Now we just need to print distance is equal to front dot cleanup. Now this is a program which will work with our ultrasonic sensor, and this ultrasonic sensor will go ahead and give us a distance through this program. Now we need to run this program. First thing first, what we do is we need to wire our ultrasonic sensor. Now if you see, this is my breadboard and this is my ultrasonic sensor. So what I'm going to do is I'm going to go ahead and mount this ultrasonic sensor on the breadboard. Okay, now this is on the breadboard. Now I need to go ahead and mount it. I need to go ahead and wire it. So my connections were 16 and 18. So 16 is for trigger and 18 is for echo. So let me just go ahead and count it. This is 8, 10, 12, 14, and 16. So this is 16 and this is 18. Okay, so this is 16 and this is 18. What I'm going to do is I'm going to plug this 16. 16 is our trigger. So I'm going to plug this 16. If you see, it is given on the sensor, which is our trigger, which is my third pin. Now plug my third pin here, and echo I'm going to plug in the 18. Before I do that, I need to connect a 5-volt connector to this and a ground connector to this. So I'll connect our 5 volts to this. This is our 5 volt. And this is going to be ground, which is the pin number 9. Now, since that pulse which is going to come from the ultrasonic sensor is going to be huge, so what I'll do is I'll remove this so that I can show you better. So I will connect some resistors. So I need a 1K resistor and a 2K resistor for this. So let me just see if I have a 1K resistor here and a 2K resistor. So this is our 1K resistor, which looks to be very thin. This is ceramic resistor, and this is my 2K resistor. So what I'm going to do is I'm going to plug this 1K resistor with 2K. So okay, so my wiring is ready. Now this might look a little bit confusing, but it's not that confusing at all. So you can just follow the diagram and you can just go ahead and wire it by yourself. So what you can do is to make it a little bit simpler. So if you're gonna put more than one sensors, let's say 2, 3, or 4 sensors, so you can have the trigger, the VCC, I mean the 5 volt, and the ground rails, the ground connections as common for all the sensors. And for echo, you can have each individual echo sensor for each of them, so you can have individual pins. So let's say if you have, so currently I'm using 4 pins, but what you can do is you can, for 2 sensors, you can get it done in 5 pins, and for 6 sensors, you can get it done in 6 pins. So it's going to be like that. So for 3 sensors, you can do it in 3 plus 3, 6 pins. For 5 sensors, you can do for 5 plus 3, 8 pins. So this is how you can do it, and you can just go ahead and configure it based on your requirements. So what we'll do is, first of all, we will test this sensor. So let me just go ahead and run the program. Now I will just go ahead and run it, and I will keep my hand in front of the sensor, or I'll keep some object in front of the sensor. Now, since this object is in front of the sensor, I will just go ahead and run it, and nothing. So now, as you can see, we got nothing. It's not running it. It's not, nothing is happening over here. So what we need to do is we need to debug it or troubleshoot it and try to find out where exactly is the problem. I've done a little bit of debugging on the program, and this is what our program is right now. Pretty much the code was fine. There was no issue with the code at all. What the code we wrote was, I just changed some timing, but that does not matter. So the code was pretty much okay. The code did not have any issue, but the only thing was that wiring on the sensor was incorrect. So I had placed the sensor, because my breadboard is kind of translucent, so sometimes it becomes a little hard for me to see the pins where I have to, the sockets where I have to put the pins. So because of that, the cabling was not correct. Because of that, it didn't work. So what we're going to do is, additionally what I've done is I've added a small red LED which connects from the trigger to the ground. So it connects from trigger to ground, which will identify that whether our uh, trigger is working or not. So if you can see, if I keep it too close, due to which it will not be able to detect the distance. So if you see, it will keep on blinking because it is not able to detect the distance, and it just says no signal. But if I go ahead and make some distance, like keep some distance apart, and if I run it, you see I just get it like front is 20, and if I go ahead and change it a little bit, now I get 17. Now, as I told you, if the object is at an angle, so if I put it at an angle, so let's see what happens. Now if you see, the front says 1914 38. So this is not a correct measurement, because it's bouncing also. If I put my hand here, which will triangulate this thing, and now if you see, it is showing as 23. If I bring my hand closer, it shows as 19, because it is hitting it an angle and it's bouncing back to the sensor. So this is our program with one ultrasonic sensor now. So what we'll do is, next is, since this sensor is working, we will integrate this sensor with our car. So right now we have only one sensor, and we will put this one sensor in our program and make it as a function. And then similarly, so this is our front sensor. Once this is functional, we can do it for the left sensor, right sensor, and reverse sensor. So we can have like 4 sensors, and with those 4 sensors we can just go ahead and start running our program. So what I'll do is, I will in the meanwhile go ahead and prepare the program, and I will just give you a rundown on how that program works, so that we can start using it. Now also, I will just go ahead and mount my entire setup on the car, and then we will run it. So that's all for this video for now. If you like this video, please click on the like button. If you have not subscribed to my channel yet, please subscribe, and if you have any questions or queries, please post it in the comment section below, and then I will answer this. And also, all this code and everything, I will update it in a Google Drive or some kind of cloud-based drive, and I will make it available for everybody so that you guys can download it and run it as is, so it will be easier for you as well. So till the time, have a good day and goodbye.